Hello and welcome to my YouTube channel ChemWis. In this video we are going to discuss IUPAC nomenclature of alkenes. There are several common points between IUPAC nomenclature of alkanes and alkenes. We will not be discussing those common points in this lecture. In this video we will discuss only points which are specific to alkenes. These are the following steps involved in IUPAC naming of alkenes. Step 1. Identification of parent chain. In the case of alkene, parent chain is the longest chain containing both the carbon atoms of alkenic double bond. For example, in this alkene molecule, there are 3 carbon chains, a 6 carbon chain without carbon atoms of double bond, a 5 carbon chain with both the carbon atoms of double bond, and a 6 carbon chain with both the carbons of double bond. So there are 2 longest chain, one has both the carbons of double bond and another doesn't have any carbon atom of double bond. So this longest chain with both the carbon atoms of double bond will be the parent chain. Let's have one more example. In this molecule also there are 3 carbon chains, one with 8 carbon atoms and with only 1 carbon atom of double bond, a 6 carbon chains with both the carbon atoms of double bond, and a 5 carbon chain with both the carbon atoms of double bond. So the 6 carbon chain with both the carbon atoms of double bond will be the parent chain. Step 2. Numbering of parent chain. Parent chain is numbered in such a way that the carbon with the double bond receives the smallest possible number. For example, in this molecule, this is the parent chain. Number it from left to right as 1, 2, 3, 4 and 5. From right to left 1, 2, 3, 4 and 5. Here we can see that the left to right numbering gives the lower number to the carbon with the double bond. So left to right numbering will be the correct numbering. One thing which is to be noted that when there is alkene and substituent both, then alkenic carbon gets the lowest possible number. If both the sides of numbering give the same number to the carbon with the double bond and there is only one substituent, then the branched carbon receives the lowest possible number. For example, in this molecule, numbering from left to right and right to left both give the same number to the alkenic carbons. And there is one branched carbon atom in this molecule. Since numbering from right to left gives lower number to the branched carbon, so right to left numbering will be the correct numbering. If both the sides of numbering give the same number to the alkenic carbon and there are more than one branches, then rule of first point of difference is followed, according to which the correct numbering gives the smallest possible number at the first point of difference. For example, in this molecule, both the sides of numbering give 4 and 5 number to the alkenic carbons. There are 2 methyl groups. In left to right numbering, the 2 methyl groups are at C4 and C7 positions, while in right to left numbering 2 and 5 positions. Since right to left numbering gives lowest number at the first point of difference, so right to left numbering will be the correct one. If there is tie at all the points, then follow the alphabet rule, according to which correct numbering gives lowest possible number to the branched carbon with group that comes first in alphabetical order. For example, Let's take this molecule. We can see here that both the numbering give same positioning of carbons with the double bond and also the branched carbons. So here we have to follow alphabet rule. In this molecule, the two substituents are ethyl and methyl. Since ethyl comes before methyl in alphabetical order, so the numbering starting from left to right will be the correct, as it gives lower number to the branched carbon bearing ethyl group. Step 3. Writing names of substituents. Substituents are placed in alphabetical order indicating their position before the name of the parent chain. I am not going to discuss this part in detail in this video, as I have described fully in a separate video of IUPAC nomenclature of alkanes. You can find that video by clicking on I button or link given in the description box of this video. Step 4. Writing configuration of double bonds. If there is one stereogenic double bond. Stereogenic double bond means a double bond that shows geometrical isomerism. Then the configuration E or Z is written in italic at the beginning of name of the molecule in parenthesis, which is then connected to the substituent name with a hyphen. Here there is no need to write the position of double bond before E and Z. I have made a separate video on how to find E and Z configuration of alkenes. You can find that video by clicking on I button or the link given in the description box of this video. Let's have this alkene. It has only one double bond and that has Z configuration. Then in the IUPAC name of the molecule, its configuration will be mentioned as in parenthesis Z. Let's have another example. This molecule has two double bonds but only one is stereogenic. So in this case too, it is not necessary to mention the position of a stereogenic double bond, and therefore in the IUPAC name of the molecule, its configuration will be mentioned as under parenthesis E. If there are more than one stereogenic double bonds, then in this case the position of double bond is also mentioned along with the configuration E or Z. For example, let's have this molecule. It can be labeled like as: there are 3 double bonds out of which 2 are stereogenic. The configuration of double bond at C3 is Z, while that at C7 is E. So in the IUPAC name of stereochemical information will be written as 3Z7E. Now come to the fifth and final step, in which we will merge all the informations to get IUPAC name of alkene. The IUPAC name of an alkene with one double bond consists of 5 parts: configuration of alkene, substituents, position of double bond, parent chain, and suffix "ene." There is one more general structure in which there is shuffling between the double bond position and parent chain. So the structure becomes configuration of alkenes, substituents, parent chain, position of double bond, and suffix "ene." While merging these 5 segments, we should take care of these points. There should not be any space, dash or comma between two alphabets. Two numbers are separated by comma and number and alphabet are separated by a dash. Now we will do exercise. Let's first have very simple alkenes with 2 and 3 carbon atoms. 2 and 3 carbon alkenes are very simple. They have only parent chain, non-ambiguous position of double bond, no stereochemistry and no substituents. So their IUPAC name is written as parent chain plus ene. While combining these two, there will not be any space, comma or dash because two alphabets are combining together. Thus, CH2 double bond CH2 is named as eth plus ene is equal to ethene, and 3 carbon alkene CH2 double bond CH3 is named as prop plus ene is equal to propene. Let's have this 4 carbon alkene. We will go step by step. Parent chain. It has 4 carbon chain, so it will be named as bute. Numbering of parent chain. Number the carbons from left to right as 1, 2, 3 and 4, and from right to left 1, 2, 3 and 4. Since left to right numbering gives lower number to alkene, so left to right numbering is the correct numbering. Position of double bond. It is 1. Substituent. There is no substituent. Configuration. There is no stereochemistry. IUPAC name will be configuration plus substituent plus position of double bond plus parent chain plus ene. Since there are no substituents and stereochemistry, so IUPAC name will be position of double bond plus parent chain plus ene. So the IUPAC name of this molecule will be 1 plus bute plus ene. While joining, there will be dash between numbers and alphabet and no space, comma or dash between alphabets. So the IUPAC name will become 1-butene. We have also learned that this can also be named by switching the position of double bond and parent chain where all the 3 segments are connected through dash. So we can also write the IUPAC name of this compound as but-1-ene. Another example. Parent chain. It has 4 carbon chain, so it will be named as bute. Numbering of parent chain. Number the carbons from left to right as 1, 2, 3 and 4, and from right to left as 1, 2, 3 and 4. Since left to right numbering gives lower number to alkene, so left to right numbering is the correct numbering. Position of double bond. It is 1. Substituent. There is 1 methyl at position 3. So it will be written as 3-methyl. Configuration. There is no stereochemistry. So the IUPAC name will be configuration plus substituent plus position of double bond plus parent chain plus ene. Since there is no stereochemistry, so IUPAC name will become substituent plus position of double bond plus parent chain plus ene. So the IUPAC name of this molecule will be 3-methyl plus 1 plus bute plus ene. While joining, there will be a dash between number and alphabet and no space, comma or dash between two alphabets. So the IUPAC name of this molecule will be 3-methyl-1-butene, or in a different way we can write it 3-methyl-but-1-ene. More example. Parent chain, it has 7 carbon chain, so it will be named as hept. Numbering of parent chain. Number the carbons from left to right as 1, 2, 3, 4, 5, 6 and 7, and from right to left 1, 2, 3, 4, 5, 6 and 7. Since left to right numbering gives lower number to alkene, so left to right numbering is the correct numbering. Position of double bond, it is 2. Substituent, there is one ethyl group at position 5, so it will be written as 5-ethyl. Configuration, there is only one stereogenic alkene with E configuration. IUPAC name will be configuration plus substituent plus position of double bond plus parent chain plus ene. So the IUPAC name of this molecule will be E plus 5-ethyl plus 2 plus hept plus ene. Now combine these segments to get IUPAC name, which is E 5-ethyl 2-heptene, or in a different way we can write E 5-ethyl hept 2-ene. Now we will talk about IUPAC nomenclature of polyenes. Polyenes are the compounds with more than one CC double bonds. The general structure of IUPAC name of polyenes is written as configuration, substituent, position of double bonds, parent chain with suffix A, numerical prefixes like di, tri, tetra, etc. to indicate the number of double bonds, plus ene. Here the parent chain is the carbon chain with the maximum possible number of unsaturated carbon atoms. Let's go through examples for more understanding. In this molecule, this is parent chain with 4 carbon atoms. It will be called as but. You can number the chain from any side as 1, 2, 3 and 4. Position of double bond, it is 1 and 3. Substituents, there is no substituent. Number of double bonds, it is 2. So numerical prefix will be di. So the IUPAC name will be configuration, substituent, position of double bond, parent chain with suffix A plus di, tri, tetra, etc. plus ene. So it will be 1,3-butadiene. Let's have one more example. Parent chain. This is the parent chain having 8 carbon atoms. So it will be called as oct. Numbering of parent chain, it will be done from left to right as 1, 2, 3, 4, 5, 6, 7 and 8. Position of double bond, it is 2 and 4. Substituents, there is 1 methyl at C5. So it will be written as 5-methyl. Configuration of double bonds, it is Z and E. So it will be written as 2Z4E. Number of double bonds, 2. So numerical prefix will be di. Thus the IUPAC name of this molecule will be configuration plus substituent plus position of double bonds plus parent chain with suffix a and numerical prefix plus "-ene", which will be equal to 2Z4E plus 5-methyl plus 2,4 plus octa plus di plus "-ene". So the IUPAC name of this molecule will be 2Z4E 5-methyl 2,4-octa-diene. That's all in this video. Please subscribe my channel and press the bell icon if you like this video. Thank you very much for watching this video.